We've now got a better idea of how classes work in Dart, so in this section we're going to move forward and start working on our next application that is going to make heavy use of classes. Let's get started by talking about what we're going to be making. Alright, so you and I are going to make a little program that's going to simulate a deck of playing cards, like the same kind of cards you would use to play poker or blackjack or even go fish for that matter. Inside of our deck of cards will be a list of 52 different cards. Every card will have a rank, which would be like the ace, 2, 3, 4, and so on, and a suit, which would be diamonds, hearts, spades, and clubs. I want to make sure that our program is going to have some reasonable amount of functionality so that it can simulate actually playing with a real deck of playing cards. So for example, inside of our program, I want to have the ability to create a new deck of cards. We should have the ability to, say, shuffle the cards inside that deck, and also deal a new hand of cards as well. So let's take a pause right here. We're going to come back in the next section and start talking about the design process of how we're going to actually make this application. So quick break, and I'll see you in just a moment. In the last section, we started talking about the next application that we're going to be working on. This application is going to have a heavy focus on object-oriented programming, particularly on the design aspect of how we set up the different classes inside of our application. So to that end, I put together a diagram that's going to help walk us through a design approach for designing our application. So here's the diagram on the screen right here. The diagram is a little bit confusing. We start off first at the top left-hand box, then we move over to the green one to the right of that, and then we go down to the next row, and so on. So inside this section, you and I are going to tackle this first row here. We're going to start off by thinking about the different types of things that exist inside of our application. And then we'll create a Dart class to represent each of those things. Then over time, we'll start to add on fields and add on methods to those classes as well. Now before we start walking through the design of this cards application, I just want to throw out there really quick that inside of any object-oriented programming approach program, there's not necessarily one right way of doing things. There might be several different designs that are totally appropriate to use inside this application and throughout all the other apps that we're going to work on through this course. So if you come up with your own design that you think works better, that's totally fine. There's nothing to say that your design is right or my design is right. They're just different approaches. So with that in mind, let's think about some of the different types of things, or classes essentially, that exist inside of our cards application. Now as I look at this diagram right here, I really see two separate things. I think the first kind of thing that we might want to model inside of our application would be very obvious. It might be an individual card. So we might have an individual card class that represents every single card inside of our application. But then the second thing that kind of exists here that's kind of a little bit harder to see is the overall collection of cards as well, or the overall deck of cards. A card by itself is kind of meaningless. A card by itself really just has a suit and a rank, like the ace of diamonds. It's only when we take a collection of cards and assemble them together do we get some actual meaning out of our program. So in total, I think we have two separate things here. I think we have a deck class that's going to have some number of fields and methods tied to it, and I think we're also going to have a card class that's also going to have some number of fields and methods tied to it. So with that in mind, let's move on the diagram. So this step 2 right here says that we're going to create a class to represent each type of thing that we're going to have inside of our app. So I'm going to flip back over to Dartpad. I've still got a bunch of code here. If you want to, you could certainly copy paste this over to some other file and save a reference to it. But for me, I'm just going to highlight all of it and delete it. And then I'll create two separate classes. The first one is going to represent the deck of cards, and then the second one will represent an individual card by itself. Okay, so very humble beginnings here. Let's take a pause and we'll continue with step 2 of this flow right here inside the next section. So quick break and I'll see you in just a minute. In the last section, we started working through our Dart program design flow here that's hopefully going to give us a reasonable OOP design for our application. We went through step 1 and we ended up saying that we're going to have two classes inside of our application. One to represent a single card, and then one to represent a collection of cards. We're now going to move on to step 2, where we're going to think about the different properties or fields that are going to belong to each of these classes. So we need to begin by thinking about the different pieces of data that should be tied to each of the things that exist inside of our app. Now I'm going to go back over to my diagram of our deck of cards over here, and we'll first begin by thinking about the different fields or properties that should belong to an individual card, so specifically the card class. So I'm going to drag a card down here just so we can study it in great detail by itself. So as I look at this individual card, I can really only think of two properties that should belong to this thing. The first is the rank of the card, in this case ace. So the rank of a card would be like ace, 2, 3, 4, 5, 6, 7, all the way up to 10, jack, king, queen, and so on. The other property that I think this should have should be the suit as well. So is this a card of diamonds or of spades, of hearts, of clubs? So in total, I think that our card class will have two properties associated with it. The rank right here and the suit right here. The other thing I want to mention is I think both of these fields will be of type string. I think that makes a lot of sense in the case of the suit right here. We should store a string of like literally diamonds. In the case of the rank, you could definitely make a case for saying that we should store that as an integer, where 1 would represent an ace, and then maybe 11 would be jack, queen would be 12. Am I doing that right? Yes, king would be 13. But I think that in this case, just using a string to indicate the rank makes a lot of sense as well, because the end goal here is going to be us wanting to actually print out some information about these cards, and it would definitely make a lot more sense to display that as a simple ace, queen, king, rather than having to deal with some integers. Okay, so I think that takes care of the individual cards. Now the other class we have to think about is the collection of fields, or the different properties, that's going to belong to the deck class. Remember that we had just said that an individual card doesn't make a lot of sense by itself. It's only when we combine together a bunch of cards into a deck that we start getting an interesting application, and we can actually make a game out of it. So I think that for the properties that belongs to the deck, we'll probably just have one single property or one single field, and that will be a list of cards, exactly as you see right here. So every deck instance inside of our application will have a collection of card instances somehow associated with it. Okay, so let's take these kind of decisions about our design. We're going to go back over to our design flow here. So we just did this thing right here. We thought about the different pieces of data that should be attached to each thing. We're now going to want to create a field on each class that's going to hold that type of data. Now, one other thing I want to look at very quickly is just a summary of what we're deciding at this point. So for the card class, we're going to have a suit of type string and a rank of type string. Then for the deck class, we're going to have a cards property. So this cards property right here is going to reflect all the different cards that belong to this particular deck. And it's going to be of type list of cards. Now I want to very quickly zoom in on this because the syntax I used here is actually somewhat important. Okay, so I'm going to blow up the text here. Let's do 36. There we go. So the syntax I used here to indicate this type is something that we're going to see inside of our Dart code as well. This means that the cards property over here should be a value of type list that contains only instances of cards. So the kind of little braces right here, or brackets that you see right here, means to say that inside this list, we're just going to have values of type card. The other thing I want to mention is what this list thing right here is as well. So in Dart, we have arrays, kind of, but we don't call them arrays. Instead, we call them lists. So when we say list of cards right here, you can also think of this as being like an array of cards. Same type of thing. But to actually list that out, or to actually designate that, we would write list and then card inside of the braces. Okay, so let's now flip back over to Dartpad, and we're going to add on these fields to our program. So we'll go back over to Dartpad, here we go. And then remember the syntax that we use for adding fields to a class. We write out the type that we want to add to it. So in this case, I'm going to add a string and then the name of the field. So for the card, we're going to deal with a suit, and we're going to have a string of rank as well. Then for the deck, we're going to do the same thing. Now in this case, we want to say that we're going to have a type of list with cards inside of that. So to indicate that type on our class right here, we can write out list, card, and then cards. So just the same as what we did right here, where we put down the name of or the type of the property and then the name of the property, we did the exact same thing up here as well. So the name of the property is going to be cards, and it's going to be of type list containing nothing but cards. Okay, so we just got through step 2 of our design flow here. Let's come back to the next section, and we're going to start thinking about adding methods to represent each of these classes. So quick break, and I'll see you in just a minute. We're now ready to move on to step 3 of our design flow here. So in step number 3, we want to think about all the different ways that we're going to interact with each thing inside of our application. The end goal of this step is to figure out the different methods that need to be added to each of our classes. I'm going to go back to the diagram that we were looking at earlier that described all the functionality that we wanted to see in this program. So if you look at all these steps right here, or all the things we want to do, it's all seeming to revolve around working with a deck of cards. None of these functions really seem to belong to a single card by itself. In other words, you can't really shuffle a single card. You can't really, find a single card with a given suit. That doesn't make a ton of sense. So really, I think that all these different functions or pieces of functionality that we need to add to our application are going to be tied directly to the deck class. So in total, I think that we're going to end up with a solution like this, where we've got our deck class right here with the methods like print cards and shuffle and deal and so on. And I don't think that we're going to quite need so much over here on the individual card side. So with that in mind, let's take a quick pause. We're going to come back to the next section, and we're going to start working with that first function right here, where we want to have the ability to create an entire deck of playing cards. So quick break, and we'll start the implementation in the next section. In the last section, we started talking about how we're going to begin adding different methods to our deck and card classes. We'll first begin with this first task up here. So we want to have the ability to create a new deck and make sure that there are 52 playing cards inside of it. Remember, a standard deck of cards has 52 cards. 4 suits and 13 ranks, or however many, 13 ranks. Now, one thing I want to make really clear here is that even though I'm kind of indicating right here that these are a bunch of methods that are going to exist on the deck, this make a deck function right here, well, it's a little bit different than the other functions you see listed on here. Well, let me tell you why. I want you to imagine that at some point in the future, after we finish up this deck class and the card class, we end up writing out our main function. And then maybe inside this main function, you and I write some code to create a new instance of the deck class. So maybe we would write something like var deck is new deck. Now, I don't know about you, but I would really expect that the instant I called new deck right here, I would just poof, magically get 52 cards added for me to this cards property or this cards field. I would not want to have to run some additional method or additional function like, say, deck add all cards, or something like deck build my cards, or something like that, to generate those 52 cards and add them to this list. In other words, I want to make sure that the instant I create a new deck, I automatically get 52 cards added to this cards property. So what I'm kind of driving at here, long story short, I think that we need to add a constructor function to the deck class. So the instant we create a new instance of deck, we automatically get the opportunity to do some initialization of our deck class and add those 52 cards in without having to require an extra function call like that or any additional kind of hubbub to get this class initialized. So I'm going to clean up this main function right here, and then inside the deck class, I'm going to add on my constructor function. We just spoke about constructor functions a moment ago. Remember, to define one inside of a class, we write out the exact name of the class as a function inside the class body. So because my class's name is deck with a capital D, I'll add on a new function called deck, place my parentheses, and then my curly braces like so. So now this function right here is going to be called automatically every time we create a new instance of a deck, which makes it a perfect location to create our big list of cards and add it to this cards property right here. Okay, so let's take a quick pause right now. We'll come back in the next video and start implementing the logic to add all of our cards to that cards list. In the last section, we put together our deck constructor function, which is going to be a perfect location to create our list of 52 cards and add them all to this cards list right here. Before we start just writing out some code to make that happen, let's take a quick look at a diagram that's going to lay out the strategy that we're going to use to create all 52 cards in one fell swoop. Alright, so here's the idea. We're going to begin by creating two separate lists. Each list is going to contain a bunch of strings. Now we haven't dealt too much with lists just yet, but lists are essentially identical to arrays in just about every other language. So we define a list by placing some square brackets like so, and then we separate all the elements inside of it with commas. We're going to have one list of all the different ranks, like ace, 2, 3, 4, 5, 6, 7, all the way up to king, and then our list of suits of hearts, diamonds, spades, and clubs. We're then going to write out a nested for loop. So we're going to say for every suit inside of this list of suits, and for every rank in this list of ranks, we're going to create a brand new card and add it to our cards list. Now remember, the cards list is a field on the deck class right here. Okay, so let's find our constructor function. Here it is right here, and we're going to start implementing this logic. We'll first begin by creating the ranks list and then the suits list, and we'll put together these for loops. So let's get to it. All right, so I'm going to write out first my list of, let's do ranks. So I'll say var ranks. I'll place my square brackets, and then I'll do ace, 2, 3, 4, 5, and I think that's probably enough. We could definitely go all the way up to king if we wanted to, but I think 5 is enough. And I'll do the same thing for my list of suits. So I'll do, diamonds, hearts, clubs, spades. So then we're going to put together a double nested for loop. For loops inside of Dart, again, very similar to just about every other language out there. So we write out our for keyword, and then we can very easily iterate over all the elements inside of one of these lists by placing a set of parentheses. We'll write out a variable to capture each individual element. So I'll say for var suit in suits. So this for loop right here is going to iterate over every suit within our list of suits. And then it will execute the body of the for loop right here. So then inside this for loop, we're going to set up another one. We'll say for every rank in our list of ranks. And then right here is where we can add some code to actually go ahead and create our new card and add it to our list of cards. So let's take a quick pause right here. When we come back to the next video, we're going to start adding the logic to create each individual card. So quick break, and I'll see you in just a minute. We've now got our double nested for loops put together, so we're iterating over all of the suits and ranks within this list. Now inside of this body right here, we need to create a new instance of a card, and then put that card into our big list of cards inside the deck. Now to create the new card itself is going to be pretty straightforward. So to make the card, we can say var card is new card. Very similar to how we've called other constructors or created new instances of classes before. But there's one thing I want to mention here. When we create our new card right here, we probably want to pass in the suit and the rank that we're currently iterating over, so that this newly generated card right here knows what suit and rank it's supposed to represent. But if you look down at our card class, we have not yet set up a constructor function on this thing. So if we called new card right here, well, this would definitely work, but we do not yet have the ability to pass in the given rank and suit of the card. As a matter of fact, when I add that code in, I'm probably going to end up seeing an error. Here it is right here. So too many positional arguments, 0 expected, but 2 found. So this is complaining and saying, hey, you're passing in the rank and the suit, but the card is not set up to expect those arguments whatsoever. So down inside the card, we're going to add a constructor function here as well. And we're going to make sure that if we pass in the rank and the suit, we take them and initialize the appropriate properties on our card instance. Now this is another thing we did previously just a moment ago with our person class. So we're going to write out some very similar looking code. So inside of my card class, I'm going to add on a constructor function. And then remember the shorthand form that we can use to take some arguments and automatically assign them to some fields that belong to this class. So notice that the rank is the first argument here. So I can take that first argument and automatically assign it to this rank property here by writing this.rank. And then I'll repeat the same process for the suit as well. So I'll say this.suit. So now whenever we call new card and pass in the rank and the suit, those two properties will be automatically assigned to the relevant fields on the card instance. So now we've got the appropriate card created here. And this code right here is going to run 52 times, once for every combination of suit and rank. Well, for me, not 52 times, but you get the idea. So now that we've created the card, we need to take that card and add it to our list of cards. To add a new element to a list, we can reference the list itself, which is going to be in this case simply cards. Remember, in Dart, we don't have to say this.cards or anything like that. We optionally can, but we do not have to. So I'll simply say cards, and then to add a new element, I'll say add, and then I'll pass in the element that I want to add to that list, like so. Okay, so this is looking pretty good. I am going to tell you that there is a very subtle error inside this code right now. Okay, so there's a very small bug. Let's add in a new main function to this file so that we can test out this new deck class. And then when we run that code, we're going to see that error kind of appear, or the very subtle bug appear. Then we'll take a quick pause and talk about what's going wrong. So let's add in the main function at the very top. Up here, I'll add in void main, and I'll just create a new deck by writing out new deck. And then we don't have to actually do anything with that. I just want to run the constructor function. Okay, so I'll click on run, and then you're going to notice an error message on the top right up here. It says .add is not a function. Okay, so like I said, very subtle error in here. So let's take a quick pause. We'll come back in the next section and try to figure out exactly why we saw this error message. So quick break, and I'll see you in just a minute. In the last section, we finished up our constructor function and tried to run our code, but we got this nasty error message that said null_methods.add is not a function. And so just based on the presence of the word add right here, I'm going to assume that the error is coming from this line of code, just because I see the word add. So let's talk about what's going wrong right here, and it's going to tie back into a topic that we discussed much earlier inside this course. So I want to remind you about this diagram that we looked at way before. In this diagram, we broke down a single declaration and initialization of a variable. We had said that to the left of the equal sign, we went through a process called variable declaration, and then by putting in the equals and some value over here to the right, we went through the process of initialization, which was to actually assign a value to that variable we created. We also took a look at a diagram that was this one right here. So we had said that when we create that variable, or when we declare it, what we're really doing is creating kind of a reference inside the memory of our computer. And that reference has the ability to kind of point over to some other value that also exists inside of memory. So how does this relate to the error message we just saw? Well, let's look at this line of code right here. On this line, we declared a new field tied to our deck class called cards. This line of code right here is solely a variable or a field initialization. So as we said just a moment ago, initialization is just the fact of saying, hey, there's a variable out here called blah, and here's its type. So what we really just did was to declare a new variable with a type of list that contains a bunch of different cards, and it has a name of cards. But what we did not do was any type of variable initialization. We did not set any value to this variable. So if we think about how this variable currently exists inside of memory as our program stands right now, it kind of looks a little something like this. We've got that cards variable over here to the left-hand side, but then it has not been initialized yet. We've not said, okay, and here's the value that is assigned to that variable. Whenever we declare a variable and do not initialize it, which is what we're doing right now with cards, that variable gets a default value of null inside of our application. And so that's what you're seeing right here with this error message. The error message says JS, which is short for JavaScript, null_methods.add. So null right here is really the key word. It says null because we declared this field right here, or we declared this variable, but we did not actually assign a value to it. And so by default, if we do not assign a value, we get null for that value or for that variable instead. So when we call cards.add, we're essentially saying null.add, and then we try to pass in the card. And of course, null does not have a function called add, which is why we see this error message. Okay, so that might be way more detailed than you want to know, but I can almost guarantee you this is an error message that you're going to see on your own, especially in your own projects as you get started with Dart. So I wanted to put in a little bit of discussion about why you're seeing this error message. Now to fix this error, we can do a very simple thing. Remember what we did back here? We had said that we do our variable declaration and then our initialization. So that's exactly what we're going to do. We're going to make sure that we initialize that variable. So to initialize that variable, here's my deck class right here. Here's the variable declaration. To initialize it, we'll put in our equals, and then we're going to assign an empty list to this thing. To assign an empty list, we just put down square braces like so. So now we've got the full process. We do our variable declaration, we then initialize it, and then down inside the constructor, when we call the add method that is supposed to be a part of any list object, cards is no longer null, it is now an initialized list. And the add function exists on that list, and we should be good to go. So let's try running this code now and just verifying that we do not get an error message. Okay, so no error message anymore. We don't see any output, but that's totally fine because we're not currently doing any log statements or anything like that. Okay, so in this section we spoke a little bit about how whenever we declare a variable, it gets a default value of null, and it's only when we actually initialize the variable do we get a usable value assigned to it. So now that we've covered that kind of corner case, let's continue in the next section. In the last section, we finished up the constructor on the deck class. Now, I'm going to assume that everything worked correctly, but in reality, I don't really know. It would be really great if there was some way that we could kind of inspect this cards property right here on the deck that we created inside of our main function. For example, maybe if we could print out that entire list of cards to the terminal or the console over here, we could then verify that the correct number and type of card is getting added to the cards list right here. So let's try that out. Let's try using that print function that we looked at previously to print out the deck that gets created right here. And maybe we'll be able to figure out what cards actually got inserted into this cards list. So to use that print function, I'm going to assign the deck we created right here to a deck variable. I'll then call the print function and I'll pass the deck in, like so. Then I'll click run on the top right, and we'll see what happens. Okay, so kind of underwhelming. I got an output right here of instance of deck. So what really happens when we pass a variable to the print function? I was kind of hoping we would see all the information that is contained within this deck, but instead we got this very default little bit of information. So let's take a look at a diagram that's going to help us understand what the print function is really doing for us. Okay, so here's what's happening. You and I are calling the print function, and then we're passing in, on here I put value. Technically we are passing in a variable or a reference, but I think you get the idea here. So what the print function does is it looks at that value and it says, hey, do you have a toString method? If that value has a toString method defined on it, it will be executed, and then the result of that method will be printed out to the console. So if we want to customize how any value gets printed out, we can define that toString method, and we can customize what it returns to change what actually gets printed out. Now the toString function right here that I've listed out, this is a very special function name. So when the print function is used and we pass in a value, the print function is going to look specifically for a function called exactly toString. So if we want to customize the print function, we have to define toString on our class. So let's try this out and see what happens. So I'm going to go back over to my code. Here's my deck class. So I want to customize how this thing prints itself out, and I can do so by defining the toString method on it. So I'm going to go down below my constructor, but still inside of the class body, and I'll define the toString function on here. Now, just to make sure that this works the way we expect, I'm going to first try returning a very silly string. I'll say something like, this is a deck, like so. So now that we've defined this toString function, print up here is going to call toString anytime we pass in an instance of a deck. We're going to return this string right here, and the print function is going to use this string as the representation of our deck. So let's now try running this code again and seeing what happens. Okay, and so now we see this is a deck as opposed to the previous instance of deck that we had before. Okay, so that definitely works to customize our print statement, but we're still not really able to view the data that exists inside of our list of cards right here. So let's take a quick pause. We'll come back in the next section and we're going to continue working on this toString function. In the last section, we defined a custom toString function on our deck class. So now anytime we try to print out an instance of a deck, this function gets executed. Right now, we are returning a silly string. It would be a lot better if we could somehow return our list of cards, so this cards property right here, so we could verify that the correct number and suit and rank of all those cards are being created. So maybe one way to do this would be to do something like, I don't know, let's just try returning that list of cards. Let's just see what happens if we do this. Well, when I put cards in here, you'll notice that I very quickly get an error message. So the return type, list of cards, isn't a string. So when we call or when we define this toString method, the expectation is that we're going to return a string from it, and that string should be able to be used to represent this object. So we can't just return any type of value that we want from this toString function. We have to specifically return a string. So we need to somehow turn this list of cards right here into a string. One way that we could do that is by using a built-in function on the list object. So whenever we create an instance of a list, as we are like right here, whenever we create this list right here, this array or this list has a bunch of functions tied to it. We already used one function that was tied to it. We used the add function inside of our constructor. The list right here has another function tied to it called, as you might guess, toString. So every list that we make use of inside of Dart has an automatically created toString function that has been customized to properly print out a list. So inside of our toString function, we're going to kind of delegate the printing of this object. And we're going to say, you know what? I don't know how to print out a deck. Let's just return the cards list version of toString instead. So now when we call toString on the list of cards, this right here is going to return a string representation of that list of cards, and then you and I are going to return that from our toString. And so we're kind of setting up a little bit of delegation here. So anytime that we call print on a deck, it's going to call our toString, and we are going to delegate the printing to the toString function that belongs to the list of cards. Okay, let's try running this and then seeing what happens. Okay, so I'll click on run. And now over here, you'll notice that I see what looks like a list. I see like a whole bunch of records, but what actually gets printed up is instance of card over and over and over again. Okay, well, you might be able to guess what's going on now. So we've returned a representation of that list of cards. However, when we call toString on the list of cards, that in turn calls toString on our card class as well. And so we get this huge chain of delegation of like the very top level toString gets called. That calls the cards toString, and then the cards toString in turn calls toString on the card class as well. And so that's why we are seeing this instance of card. So to fix this up, we can now define a toString function on the card class itself. And from there, we can return a string representation of the card. So let's try doing that now. Inside the card class, I'll add toString. And then inside of here, I'll return a string. And we'll try printing out something like, I don't know, let's do something that kind of makes sense here. We'll do rank of suit, like so. Remember that anytime we use a $sign inside of a string, that is string interpolation. And so this string right here is going to look at the rank property of the card instance and the suit property of the card instance. And it's going to insert them into this string. All right, so let's try running this now. So I'll run that, and now I see printed up. Much better. So we've got ace of diamonds, 2 of diamonds, 3 of diamonds, and so on. Okay, so I know that this toString stuff is a little bit strange, but essentially what's going on is that anytime we want to print up an instance of a class, if we want to have some customized message there, we can simply define the toString function and then return our own kind of custom message about what's going on with this particular record. Okay, so this looks pretty good. Let's continue in the next section. In the last 2 sections, we customized the way in which the print function represented our deck of cards and an individual card as well. So that kind of takes care of this print cards functionality right here. We're now going to move on to this shuffle function. You'll notice that anytime we print out our list of cards right here, they all appear to be in order. So ace 2, 3, 4, 5, and then starting over ace 2, 3, 4, 5. So when we first create our deck of cards, they're all created in order. Well, definitely a lot of card games out there are all based on chance, and so we definitely need to have the ability to shuffle the cards in the deck or to randomize their order. Now, we certainly could write a little bit of logic by hand to customize this shuffling, but instead we're going to rely upon a standard library function to automatically shuffle the list of cards for us. So in this section, we're going to be focused not so much on how we shuffle cards per se, but instead we're going to focus on looking up some of the standard documentation in the Dart API and get a better idea of how to read the documentation and use a lot of built-in functionality that is included with the Dart language. To get started, we're going to pull up the official Dart API documentation. So inside of a new tab in my browser, I'm going to navigate to api.dartlang.org. Now at the time of this video, Dart is still rolling out version 2, and version 2 is what we're using throughout this course of Dart. When we go to api.dartlang.org, at present, I see a page that looks like this right here, and this is the documentation for Dart version 1.2.4. But like I said, we are using Dart 2 throughout this course. So if you see this page, you'll want to find this link right here and go to the version 2 documentation. So if you see a page that looks like this when you go to api.dartlang.org, that's good. This is the version 2 documentation. So once we're here, you'll see on the left-hand side a couple of different sections. These are all portions or modules in the Dart standard library. If you've ever worked with JavaScript before, JavaScript is known as a language that has a rather weak standard library. In other words, there's not a lot of built-in functionality in a lot of the different objects that you work with. And a lot of the time, we end up having to write a lot of code from scratch to implement some very basic operations. Very much unlike JavaScript, Dart has a very strong standard library. So in Dart, whenever you make use of it, there's a tremendous amount of pre-generated code, or I shouldn't say pre-generated, but there's a lot of included code that we get for free just by using Dart. And it means that we can lean on the standard library a little bit to take care of many standard operations that we might otherwise have to write up by hand if we were making use of something like JavaScript. So what we're looking for in particular here is the core module. I'm going to click on core on the left-hand side, and then you'll notice on the right-hand side we get a listing of different classes. So these are all classes that are included in the core library of Dart. If you scroll down a little bit on the right-hand side, you'll find a class called list. So when you and I make our list of cards right now, we are creating an instance of a list. So if we look at the documentation for list, we can find a whole bunch of documentation about all the built-in functionality that comes whenever we create a list. So in particular, we can scroll down a little bit. You'll find a list of all the different ways to create a list. You'll find a list of all the different properties that belong to the list. And then you'll see all the different methods that we get for free as well. We're going to come back to this documentation quite a bit, but in this case, we're going to scroll down right now just a little bit and go directly to the function we're going to use. All right, here we go. So right here is a function or a method called shuffle. So anytime you create a list in Dart, you automatically get access to this shuffle method right here. So if we take our card list or our list of cards that exists inside of our deck, so like this thing right here, and we just call shuffle on it, it will automatically randomize the order of all the elements within that list and essentially accomplish what you and I are trying to do. So let's give this a shot. I'm going to flip back over to Dartpad, and I'm going to define a new method on my deck class. So underneath toString, I'm going to add a new method called shuffle. And then inside of here, all we're going to do is call cards.shuffle. So cards.shuffle. Cards is a reference to the list that belongs to our instance of the class. And then on that list object, we're going to call the shuffle method, which is going to automatically randomize all the elements within that list. Okay, so let's now try this out. Up inside the main function, after we create the deck, but before we print it, I'm going to call deck.shuffle. So this will invoke the shuffle method on our instance of the deck class, which in turn is going to call the shuffle method on our cards list. We then print out the deck of cards, and we should see them all randomized in order. So I'll click on Run, and then you'll notice that I now have 5 of diamonds, 4 of diamonds, 3 of spades, 5 of clubs. Clearly the list right here has been randomized. Okay, so in this section we started looking at the list documentation that is included with Dart. Like I said, we're going to be coming back to this documentation many times throughout this course and getting a better idea of how the standard library works, because you're going to be using the standard library quite a bit in just about every Dart application that you create, much more so than if you're coming from a background in a language like, say, JavaScript. Okay, so let's take a quick pause right here and we'll continue in the next section. In the last section, we took care of our shuffle function by relying upon some functionality that was implemented in the Dart standard library. We're now going to move on to our next function, which is cards with suit. Let's take a look at a diagram that's going to give you a better idea of the purpose of this function. So I want you to imagine for a second that maybe we have this deck of cards shown at the top. So ace of diamonds, 2, 3, and then ace of spades and 2 of spades. If we call the cards with suit method on the deck class and pass in a string of spades, then I would expect to receive a list back to me with the ace of spades and the 2 of spades. So essentially go through the deck and find all the cards with a particular suit. Now, one thing I want to mention here is that we do not want to modify the original deck of cards. So we're not trying to pull cards out of here. I just want to get a list telling me all the cards with a particular suit that still exist inside the deck. Okay, so let's go back over to Dartpad and we're going to start our implementation. So back over here, I'll find my deck class. I'm going to add a new method to this class down at the very bottom of the class itself. And I'm going to call this cards with suit. Now, as we just saw in that diagram 2 seconds ago, right over here, we clearly have to pass in a string that indicates what suit we're trying to find. So I'm going to make sure that I mark this method as requiring one argument that we will refer to as simply suit. So now if you want to call the cards with suit method, you have to pass in some suit argument. One thing I want to mention here is that if you click on suit and then look down at the type on the bottom right-hand side, it says dynamic suit. The word dynamic here means that Dart is not able to figure out what type of variable suit is supposed to be. So this is a good example of where Dart's going to try to figure out what's going on with your code, but it's not quite able to. Anytime Dart does not have enough information to figure out what your code is trying to do, I recommend annotating your values with a type. We've already done this a couple times inside of our project already. You'll notice that, say, on the card class right here, we specifically marked this suit as being type string, and that gave Dart enough information to figure out what type the suit property was supposed to be. But in this case, we don't have enough information. And so I'm going to specifically mark this argument as requiring to be of type string. So I want to make sure that if you ever call this cards with suit argument, you pass in a single argument that is a string. So to do so, I'll write out string and then suit. So now if I click on suit again, you'll notice that it says string suit. So we've now given Dart enough information to figure out what type of variable suit is right here. Okay, so now that we are inside of our cards with suit method and we have the appropriate type of argument, we can now write some logic to go into our list of cards and find every card with the given suit. Now you might be thinking that we're going to have to put together a for loop or something crazy like that and iterate over all the cards within our deck. But rather than doing that, we're going to again rely upon the Dart standard library, particularly some functionality that we get with every list for free. So I'm going to again pull up the list documentation. Remember, you can get here by going to api.dartlane.org, and then you'll look for the Dart core module right here. And then you can find the list section on the right-hand side. So once I'm back here, I'm going to scroll down towards the very bottom of the file. So all the way down here, right above the operator section, I'll find a method called where. So the where method right here is going to return a new lazy iterable. Let's not worry about what a lazy iterable is just yet. It's essentially kind of something like a list. But more importantly, it says that it's going to return an iterable with all the elements that satisfy some given test. So we're going to make use of this where method right here to automatically iterate through all the items within our cards list and only return the items that satisfy some test that you and I are going to write. So let's take a pause right here. We're going to come back to the next section and we're going to start our implementation of this where method. In the last section, we started talking about how we're going to use the built-in function where that belongs to every single list that we create to automatically walk through our list of cards and return every card with some given suit. So I'm going to flip back over to Dartpad and we're going to start our implementation inside of the cards with suit method that we added. So inside of here, I'm going to reference the cards property that exists inside of every deck we create. And then on this cards list right here, I'm going to call the where method. We're going to just write out the entire implementation of this method right here, and then we'll talk a little bit about how it works. So inside of here, I'm going to place another set of parentheses, and then I'll write out the word card. Then outside those parentheses, I'll add a set of curly braces. And then inside of there, I'll put return card.suit equals suit, like so. Okay, so let's talk about what just happened here. When we call cards.where, we have to pass in a function. So that's what this is right here. We defined a function without a name, and we passed it in to the where method. The where method then takes this function, and it runs that function one time for every element within the cards list. So every single card within the cards list is taken and it's passed to this function as the first argument. Then inside that function, you and I have to write some amount of logic that returns a Boolean. If we return a Boolean value of true, then that value is retained. Otherwise, if we return false, then it assumes that no, we don't care about this element. So we are looking for every card within our cards list that has some given suit. So we looked at the card.suit property and we said if this thing is equal to the string suit that was passed in to our method here, then we want to keep that card around. Okay, so that's how this where method right here works. Now the last thing we'll do is make sure that whatever gets returned from cards.where gets returned from our cards with suit function as well. And so to do so, we'll just add on the keyword return right before it. Okay, so let's now try testing this out inside of our main function. So I'll scroll up to the top and let's leave the shuffle in, what the heck, and then we'll print out the result of deck.cards with suit, and notice how we now get this nice autocomplete here with a function that you and I added. So we'll call this thing, and I'm going to try to get every card with a suit of diamonds. All right, so now I will run this code and we'll see what happens. Okay, just gonna give it a minute. Let's try it one more time here. There we go, much better. So I now get 4 of diamonds, 5, 2, 3, and ace. So clearly we went through that list and we pulled out every card with some given suit. Now one thing I want to point out here is that rather than the square brackets that we had before, we now have a set of parentheses. So if you go back over to the documentation for that where method, you'll notice that it says that it returns a new lazy iterable. So an iterable is something that is like a list, but not quite a list. We're not going to make a big distinction between the two just yet, but this is a topic that we'll come back to later in the course. For right now, I really just wanted to show you how to make use of the standard library and how to use some of the built-in methods that exist on lists already. Okay, so that looks good. So let's take a quick pause right here and we'll come back in the next section. In the last section, we put together our cards with suit method and we made special use of the where function that is included with every list automatically. In this section, we're going to do a very small refactor to this function right here to make use of an abbreviated syntax for defining functions. So I want you to notice right now that when we call where, we passed in a function that gets called one time for every element in the array. And we used what is referred to as the long-form function syntax right here. The long-form function syntax makes use of these curly braces. And we also had the return statement in there as well. Notice how the body of our function really just has one single expression inside of it. And this single expression just looks at one property and compares it to another. So this is one single expression. Because we have one expression inside of here, we can use a slightly abbreviated syntax for defining this function. So we're going to do the refactor and we'll talk about the differences between the two. So I'm going to first get started on this refactor by removing this semicolon. I'll then remove the return statement, and I'll put all this stuff on one line, like so. I'll then remove this curly brace on the right-hand side, and then I will replace the curly brace on the left-hand side with an equal sign and a greater than sign, like so. Oops, did not mean to click that. There we go. So what we have on the screen right here is completely equivalent to what we had before. So because we had one single expression, we can make use of this arrow function syntax. If we had multiple expressions or multiple lines of code, we could not use the abbreviated syntax. The other thing I want to make clear is that when we use this arrow, we get what's called an implicit return. So whatever this expression right here evaluates to will be automatically returned from the function before us. When we had the long form syntax with the curly braces, like so, we had to manually put in a return statement. So because we had a single expression and we made use of the arrow syntax, we got an automatic return for free. So if I now run this code again, you'll notice that I get the same result up here on the top right, just like I did before. We're going to be making use of this abbreviated syntax quite a bit throughout this course, and we'll sometimes also swap off back to that longer form syntax anytime we need to have multiple expressions inside of our function body. So we're going to see the syntax quite a bit both ways. All right, so we've got a good refactor here. Let's continue in the next section. In this section, we're going to move on to our next method, the deal method. The deal method is going to be pretty critical inside of our program because just about every card game in the world involves dealing some number of cards to a player. We're going to again make use of a built-in method on the list class for implementing deal. But it's not going to be quite as easy as it was the last time that we used a built-in method. Let's go look at the documentation of what we're going to use, and then we'll talk about why this is going to be a little bit more on the challenging side. Okay, so here's the list class documentation. I'm going to scroll down a bit until I find the method section. And then in the method section, I'm going to find the method called sublist. Here it is right here. So the sublist method takes two integers representing a start point and an end point. It will then return a new list that contains all the objects from that start index or that kind of start element that we passed in all the way to the end element, exclusive. So that means that it'll take it all the way, not including to that last one. So the sublist method right here is a little bit deceptive, okay? A little bit deceptive. Let me show you a diagram that's going to help you understand why. Okay, so let's imagine that you and I in the real world, okay, so this diagram right here is going to be reflecting the real world. If I had a deck of cards like you see right here, and I wanted to deal you a couple of cards out of this hand, you would probably expect to see something like this happen. You would expect to see, let me just put this in back real quick, that if I took card 0 and put it into your hand, it would be moved down. And if I took card 1 and gave it to you, it would move down to your hand as well. And so this big box down here represents your hand or the cards that I'm dealing to you. So in other words, if I give you a card out of my deck, chances are I don't retain access to it anymore. So just to be clear, that's probably how you would expect this deal function to work. If I deal you a card, I no longer have control of it. However, that is not how the sublist method right here works, and so it's a little bit surprising. Here's how sublist works instead. So a sublist, we're going to take some number of elements out of this original list, and it's going to appear that they get duplicated over to this new list as well. So when I deal you a card, it's going to appear that it stays in my hand, but it also appears in your hand as well. So this is kind of interesting on two fronts. First off, it really doesn't reflect how you and I probably want our deal method to work. You and I, for the purposes of our program, we probably want to make sure that if I deal you a hand of cards, I no longer have access to them. So that's kind of a requirement of our program. We definitely want to make sure things work that way. But the second thing that's kind of interesting is how it will appear that our card is being duplicated between these two lists. However, here's the interesting thing, okay? So this is the entire point of all this discussion about dealing these cards. These cards do not actually get duplicated when they are put into this new list. So let's take a look at a diagram that's going to help you understand how these list objects work in Dart, okay? All right, so we're going to pull up a diagram. So we've again got a diagram of the memory in your computer. So this is kind of a diagram of what's going on inside the memory on your machine when you are going to run our program. When you use Dart and you create a list, you end up putting some number of elements into that list. And we really think of that list as like containing these elements or containing these objects. But in reality, that's not quite the case. You see, when we create these cards, they are created in some random location in memory. Like maybe one's here and another one's here. And so each of these boxes represent the actual instance of the class that contains the rank and the suit of a particular card. The card object itself in memory is not actually inserted into the list. Instead, our list object right here contains a reference that points over to card number 1. Or at index number 1 here inside the list, we've got a reference that points over to card number 2, and a reference that points over to card number 3. So when we run this sublist method on this list right here and try to pull off kind of like a subset of records, the records are not actually being duplicated. Instead, we are creating a second list. It's like you can kind of imagine it appears over here. And in that list, in this brand new one, we get the exact same references that point back to those same objects. So again, it's going to appear that these cards get duplicated over to the new list, but they're not actually duplicated. It's the same exact card in memory. And so if we change the card at right here, or what appears to be right here, it's going to modify that card that appears to be over here as well, because they are not actually contained within the list. Okay, so this is this idea of references versus actual values. You might be kind of getting the idea here that it's kind of important in the world of Dart, and that's completely correct. So we really want to make sure that whenever we're working with values or references or variables, we really have an idea of which one we're dealing with. So let's take a break right here. We're going to come back in the next section, and now that we're armed with this knowledge of how that sublist method actually works, I think we'll be able to put together a working deal function. So quick break, and I'll see you in just a minute. In the last section, we had a deep discussion on how this sublist method right here actually works. So when it says that it returns a new list containing the objects from a start index to an end index, we now understand that it's not actually kind of copying those objects. It's not removing them from the original list. We are just copying references to those objects, and they never get removed from the original list. So with that in mind, we're now going to flip back over to Dartpad, and we're going to implement our deal method. We're going to figure out how to actually modify our original underlying deck when we create this hand. Because as we just discussed a moment ago, if I deal you some number of cards out of my deck, like say cards 0, 1, and 2, I definitely should not retain access to those cards. When I deal them to you, that's it. They're no longer inside of my hand of cards or my deck of cards. I no longer have access to them. Okay, so I'm going to flip back over to Dartpad. I'm going to find my deck class. Here it is right here. I'm going to go down to the bottom of that class again. And while still inside of the class body, I'm going to create a new method called deal. Now, whenever we call this deal function right here, we probably need to know how many cards we're trying to deal out to a user. For example, if we are playing a game of poker, I might need to deal you 5 cards. But if we're playing a game of blackjack, I'll probably only deal you like 2 cards or whatever it's supposed to be. So as an argument to this deal function, I'm going to expect to receive an integer reflecting the hand size, or how many cards I'm supposed to deal into your hand. Okay, so that looks good. Now the next thing we're going to do is we're going to take our cards list and we're going to call that sublist method on it. And we're actually going to call the sublist method on it 2 times. Okay, so let me give you a quick diagram of how this thing's going to work. We're going to call this sublist method 2 times. The first time, you and I are going to pull out some number of cards that are going to be returned to whoever called this function. Then we're going to call the sublist method a second time. And in that second call, remember that we're not actually removing these cards per se, so let me copy paste them back up here to reflect reality. So in the first sublist call, we're going to create this second list down here, or this kind of hand that we're going to return. And then in a second call to sublist, we're going to pull off all the remaining cards, so like 3, 4, 5 over here. That's going to give us a new list. We're going to take that list and assign it over the current cards list. So in other words, we're going to call sublist a second time. We're going to get a new list over here. We're going to throw this old list away. And then we're going to say that the new cards list that belongs to our deck class is just these remaining 3, 4, and 5. So essentially, we're just going to call sublist twice and make use of these 2 different slices. One is going to go to whoever called the deal method, and the other is going to go to the cards property on our deck class. I think that once we write out the code for this, it'll make it a lot more sense. So down here inside of deal, I'm going to first create my hand of cards, or kind of the deck or the list of cards that we're going to return from this function. So I'll say var hand is cards.sublist, and I'm going to take all the cards from 0 to hand size, like so. So with this line of code right here, we are creating a new list, and we are copying references over to that new list, and we assign all that to hand. Then after that, I'm going to call cards.sublist again, and we're going to take all the cards that are remaining inside this hand, starting at hand size. So notice how right here we took everything from the start to hand size. Then on sublist right here, we're going to take everything that is remaining in the deck. So we'll say hand size on. Now for going all the way to the end of the list here, or getting all the remaining cards, if you go back and look at the documentation here, you'll notice that around the, oops, I accidentally clicked on that. I apologize. Let's stop. No, go back. Okay, so around that second argument, there we go. Around the second argument, we've got a set of square braces right there. So whenever you see those square braces around an argument list, that means that it is an optional argument. So in other words, if we do not pass in an end argument right here, sublist is going to automatically go all the way to the very end of the list and take everything that is remaining inside there. So all we have to do is pass in sublist as the first argument right here, and then we do not have to pass in a second argument. So this line of code right here is going to take all the remaining cards inside of our cards list, and then we're going to take that brand new list that gets returned, and we're going to overwrite our current list of cards with that one. And then finally, we will return the hand that we created. And that's pretty much it. Okay, so let's test this out now. I'm going to go back up to my main method. I'm going to do a little bit of changing inside of our main method here. Let's just go back to where we had the deck. I'll start off by printing the deck. So we'll just kind of start off and say, hey, what do we have here? I'll then call print on deck.deal, and I'll try to deal myself 5 cards. So now we're going to see 2 print statements. We'll see the original deck completely unmodified. We'll then see a hand of just 5 cards, or a list of 5 cards by itself, and then we'll print out the deck again. So the second deck right here should have 5 fewer cards inside of it, because we took 5 cards and we dealt them out to, I don't know, someone who's playing our game, presumably. All right, so let's give this a shot. I'll click run up here. Give it a second. Oh, it gets stuck all the darn time. Let's try this again. There we go, much better. Okay, so right here, you'll see here is our original list of cards. That's all the cards that were created inside of our deck. Then right here, I see 1, 2, 3, 4, and 5 cards that were created inside of our hand. And then we see right here, there's clearly, I'm not going to count them all out, but clearly there are fewer cards inside of here. And actually, we can kind of make a quick comparison here. Notice how in the original list, we had 5 diamonds cards. Those diamonds are now inside the hand, and they are no longer inside of the list of cards that belong to our actual deck class. Okay, so I know that this sublist stuff was a little bit crazy, but remember the overall goal of what we were trying to communicate here is that whenever we create a list of records, the list does not actually truly store our records. The records exist inside of memory, and the list just makes reference over to the records. Okay, so now that we got a better handle on that, let's continue in the next section. In this section, we're going to take care of our last method down here, the remove card method. So the idea behind this method is that we're going to try to remove one particular card from our deck. I can't really imagine where we would use this method in a real card game, but I'm sure there's some card game out there where you have to like find the ace of spades or something and take it out of the deck. Now for this method, we're going to do things just a little bit differently. So here's what's going to happen. We're going to have you take a shot at putting the remove card method together. Okay, so you're going to take a shot at it on your own using nothing but the code that we've already got over here in Dartpad and the list class reference that we've been looking at quite a bit so far. So I'm going to give you a couple of little tips here just to get you started, and then I'm going to cut you loose. So the first thing I want to point out here is inside of the list class documentation. If you scroll down inside the documentation, so I'm going to go down, down, down again until I find the methods section. Oh, I think I just passed it. So here's the methods section, and I want to point out one particular method to you, the remove where method right here. So I want you to take a look at this method right here, and I don't know, just kind of get a sense of how it works. The remove method expects you to pass in a function to it. That function will then be executed with every element within a list. And then if that function returns true, the element will be removed, but if it returns false, the element will stay around. And so we've already worked on a very similar function, very similar in nature to this one right here. You'll recall we put together our cards with suit function right here. So this was very similar in nature, but this was where, and maybe, I don't know, maybe you might want to take a look at remove where right here. Okay, so then the other thing I want to show you very quickly is back inside of Dartpad. I really expect that you're probably going to add a new method to our class, so maybe a method right here. Maybe you're going to call that method something like remove card. I don't know, it's totally up to you. And chances are that when we call remove card, we're going to have to pass in both the suit and rank of the card that we want to remove. So whereas back on the card with suit method that we passed in right here, or the method that we created right here, we were only passing in the suit, I kind of expect that for a remove card method, we'll have to pass in both a suit and a rank to specify what card we're trying to remove. Okay, so I want you to give it a shot, do the best job you can. If you get stuck, don't sweat it. We're going to go over a solution together right in the next section. So I'll see you in just a minute. Okay, hopefully you had some success in putting this remove card method together. So again, I really think that we're going to end up using this remove where method that belongs to all lists that are created. So let's go back over to Dartpad and we're going to put this thing together. Okay, so back over here, I'm going to create a new method inside of my deck class, and I'm going to call it remove card. Now to specify the card that we want to remove, I'm going to expect that we're probably going to have to pass in the suit and the rank of the card that we're looking for. So I will receive those as arguments. I'll say string suit and string rank. If you flipped the order of these two arguments right here, that's totally fine. You can go in absolutely whatever order you wish. Then inside of here, I'm going to call that remove where method right here. Now one thing that I want to make really clear here, because this was something that might have tripped you up just a little bit, just a couple sections ago we were talking about how lists contain references to objects. So in this case, when we call remove where, whatever passed that truth or false test is going to be simply removed entirely from the list. So like that reference gets deleted. So we don't have to create a second list or worry about these copying over or anything like that. By just calling remove where, it will remove that record from the list. It doesn't actually delete the original record, but we don't have to actually worry about that. We just care about removing the record from the list. All right, so I'm going to go back over to Dartpad, and inside of here, I'm going to call cards.removewhere. Now, as soon as I add that in, you'll notice that I get the function signature right here. So the removeWhere function should receive a function of its own. I'm going to get called that thing with a card element, and I'm supposed to return a Boolean from it. So I'll place my set of parentheses. And then inside of here, I'm going to first get started by using that long form syntax for defining a function. You'll recall that back up here, we used the shorthand syntax with the arrow function, with the arrow symbol right there. But this time around, I'm just going to start easy and assume that I might need the long form syntax. So I will receive a card inside this thing. And then from this function, I'm going to return card.suit. So this is the suit that belongs to the card that we're currently iterating over. And I'm going to check to see if that is equal to the suit that was passed into our function. So if these two values right here are identical, then that means that this is probably a card that I want to remove. And then to check to see if I also want to remove the rank as well, I'm going to add in an and, like so. This right here might have been a little bit of a reach. I apologize. I didn't really tell you about how to combine Boolean values together. So if this part right here of combining two Boolean values together was confusing, I do apologize for that. And then for the second comparison, I want to make sure that we have the same rank as well. So we'll say card.rank equals, and then rank. Now just to add a little bit of clarity in the order of operations of how this entire Boolean statement gets resolved, I might choose to add a set of parentheses around each of those comparisons. It is not necessary, but we could definitely do so just to make the order there a little bit more clear. Okay, so I think this might be a working implementation here. Remember, when we call it removeWhere, like we were saying just a second ago, that modifies our existing list. It doesn't return a new list or anything like that. It modifies the existing list that we're looking at. So we don't have to worry about kind of reassigning over our cards property or anything like that. Okay, so I'm going to test this out by going up to the top of the file. Here's my main function. I'm going to remove the print statements that we have right now. I'm going to call the deck.removeCard method. As a first argument, I'm going to pass in a suit. So I'm going to try to delete this ace of diamonds right here. So the suit that I'm going to try to delete is going to be diamonds. And then the rank will be ace. And then after I attempt to remove that card, I'll print the deck out. And I'll just verify that the ace of diamonds is no longer inside there. Okay, so I'll run. And okay, that looks great. So we no longer have the ace of diamonds in there, and our deck starts off first with the 2 of diamonds. Now the last thing that I might want to consider is to refactor this long form syntax right here into a single arrow function as we had done previously with the cards with suit method. Now this would definitely be a candidate for that refactor because we have a single expression here. Even though it looks like we're doing multiple operations, it's still overall a single expression. It doesn't span multiple separate lines of code. So I could do a little bit of a refactor by removing the return keyword, removing the semicolon, removing the curly braces, and then putting an arrow inside of here with equals and then a greater than sign. All right, so that should definitely be appropriate or equivalent. You'll notice that it kind of looks like it gets scrunched up onto 2 lines there. You might see something that looks a little bit more like that, which looks a lot better. But like I said, the two are 100% equivalent, so it's really up to you which way you want to go. I'm going to run this one more time just to make sure that refactor did not break my code. And in fact, it looks like we're good to go. Okay, so that's pretty much it for our deck class. So we've gotten a better sense of how classes work, and we've also done a real deep dive on some of the documentation around lists and gotten a better idea of how references work. Now there's still a ton of stuff for us to learn about Dart, so let's take a quick break and continue in the next section. There's one last little item that I want to point out about our current deck implementation. If we scroll down to the deck constructor, so here it is right here, and find our double nested for loop, here it is right here, we'll find the card constructor. At present, we are passing in the rank as the first argument and the suit as the second. Now, I want to show you a very easy way that we could introduce a kind of nasty bug to our program. If I were to swap the order in which I pass in the rank and the suit, so now it's suit and rank, I get absolutely no feedback telling me that I just made an error. In fact, I can still run the program successfully, but now I get some very weird output. I see diamonds of ace, diamonds of 2, and diamonds of 3, and so on. So this is definitely a nasty little bug, and I get no feedback from Dart telling me that there's any issue here whatsoever. So in order to help you and I solve issues like this, where we have some very specific order of arguments that are expected, Dart has a feature called named parameters. So rather than just passing in the suit or the rank as the first argument and the suit as the second, we can name the parameters that get passed into this card constructor, and then we can provide those named parameters in any order that we wish. So let's do a little refactor here, and you'll get a better idea of what I mean. I'm going to first start by adding a new line character in here, like so. And then I'm going to put a new line after rank as well. Okay, now here's the refactor. I'm going to say suit, suit, and rank, rank. Now we immediately see an error message, but we'll just ignore that for a moment. What we just did is provided named parameters to the card constructor. Now the left-hand side of each of these colons is the name of the argument or the name of the parameter that we're trying to provide to the constructor. The fact that the variable name is suit on the right-hand side is not relevant at all. The name of the parameter and the actual value that we provide do not have to be identical. So in other words, I could change suit right here to my suit and change that right there to my suit as well. And now this would be completely equivalent to what we had before. The name that we provide to the parameter is not at all tied to the actual variable itself. Now we'll go down to our card constructor, where we're going to massage it a little bit and tell it that it should expect to receive a named argument list. So down at the bottom of the file, I'm going to find my card class. Here's my card constructor. And then all we have to do to tell our card constructor that it should expect some named arguments is add a set of curly braces around this.rank and this.suit like so. So now, anytime we create a new card, we're going to pass in a variable named suit and a variable with name of rank. And then down inside this constructor, the constructor is going to look and see that it's being provided a list of named arguments, and it's going to try to find in that list one argument named rank and one named suit. It's then going to extract those arguments and assign them to the appropriate instance variables. So now I should be able to run this code, and I see correctly 2 of diamonds, 3 of diamonds, 4 of diamonds, and so on. So the benefit here is that by having these named parameters, when we create our card, is that we no longer have to remember the order in which we have to pass these in. I can freely rearrange this order as much as I please. So I can put that rank first, and then suit second. I can run this, and everything is still going to work the way I expect. Okay, so that's pretty much it. That's named arguments or named parameters in Dart. So let's take a quick pause right here and continue in the next section.